Start now.
Graphs of rational functions, page 1, where the degree of p is less than the degree of q. You get p over q for all of these functions. So for the first example, f of x equals 1 over x. We know that as x gets really large, the y values are going to get small because 1 divided by a small number tends to be 0. For example, f of x, or notation, f of x is heading towards 0 as x is heading towards infinity. Same thing on the negative side. F of x is heading towards 0 as x goes to negative infinity. Just plug in very large numbers or very large negative numbers and you will see that's true. Also, just wanted to review the notation that as x approaches 0 from the right, that's what the little plus sign means, then we're talking about numbers slightly bigger than 0, the y values will go to infinity. So f of x will go to infinity. Same thing as x approaches 0 from the left, we're talking about this region, then the y heads towards negative infinity. We're going to move on to g of x. One way to think of g of x is as a transformation of f of x. You know from what we've learned in the past that g of x equals f of 2 minus x, which equals f of minus x minus 2. You know that the negative causes a reflection over the y-axis, which would get us a shape like that. And then the x minus 2 shifts it 2 units to the right, which gets us the graph you see here for g of x. And on this, just to review the notation one more time, as x approaches 2, right here, from the negative, that's the left, then the y values are heading towards infinity because you have things like 1.9, that would be approaching 2 from the negative, or 1.99. These numbers are slightly less than 2. 2 minus them will be positive. 1 divided by a small positive number is infinite. As x approaches 2 from the positive, g of x is going to go to negative infinity because it's the same situation except we're going to have small negative numbers. And again, g of x is going to 0 as x goes to either plus or minus infinity. That gets us the shape of g. We're going to move on to h. For h, before I move on, I just want to make a general comment. For any of these graphs, all 4 of them, the vertical asymptotes are happening when the denominator is getting close to 0, which happens when we get close to the factors of the denominator. So for h of x, if you factor that, you get 2x over x minus 1 times x plus 1. So we know that it's got to have our vertical asymptotes at 1 and minus 1. What we haven't figured out yet is why we picked where it's positive and where it's negative. To do that, I'm going to create a sign chart like we did when we were solving inequalities. Put the zeros from any factors, whether they come from the top or the bottom, on the sign chart, and then just do a little analysis. If you plug in a number way larger than 1, or at all larger than 1, every single one of these 3 factors is positive. So the whole thing will be positive. And then at each 0, the sign chart will change. The sign will change. So that tells us which regions h of x is positive in, where it's negative, where it's positive again, negative again. There's one other little analysis I want to show you that will help make sense of the fact that the graph is going to 0 as x goes to plus or minus infinity, just as it did in f and g. So I'm going to take h of x. I'm just rewriting the equation above so I have room to work with it. 2x over x squared minus 1. And now I want to take the largest degree value term in here, which is x squared, and I want to multiply by 1 over that everywhere. That means you're going to distribute this. On top, you just have 2x over x squared, which equals 2 over x. On bottom, you're going to have x squared over x squared minus 1 over x squared. So that's going to give us 1 minus 1 over x squared. Let me just write this 2 over x more in the middle. And put this equal sign more in the middle. Now, as x goes to plus or minus infinity, this term goes to 0, this term goes to 0. We're basically left with 0 over the remaining 1, which is just 0. So that's talking about these extremes. As x goes to infinity, h, which is the y values, is going to 0. Positive where the sign chart says we're positive, negative where the sign chart says we're negative. Putting that together along with the asymptotes gets us this shape. As x goes to infinity, we're here. We have to be in the positive region, so we can't be below this. And as we approach our vertical asymptotes, we go up. In the next region, we were told we have to be all negatives, so that means I'm stuck in this, and I'm heading towards negative infinity. The next region, the sign chart told us we have to be positive. That means I have to be in this portion, and I'm heading towards that asymptote. And in the last region, it's all negative. There's no choice but to draw it like this. Last example, k of x. Again, I'm going to factor it. So k of x equals 3 times x minus 2 over x minus 2 times x plus 2. Again, the domain is going to include everything except plus or minus 2, but this time we only have a vertical asymptote at x equals negative 2 right here, which when you draw by hand you draw dotted. The reason we don't have a vertical asymptote at positive 2 is because that factor cancels, which basically means the graph of k of x is going to look exactly like the graph of just 3 over x plus 2, except with a hole at 2, since 2 is not allowed to be in the domain. So at negative 2 we got our vertical asymptote. A sign chart analysis would tell us we're positive to the right of negative 2, and we have no choice but to approach the x-axis on both extremes. And at negative 2, we've got to approach our vertical asymptote on the positive side and the negative. One general comment about horizontal asymptotes: anytime the degree on bottom is bigger than the degree on top, we're going to have this situation where y goes to 0 as x goes to infinity. So the x-axis will be a horizontal asymptote, which I'm just going to abbreviate ASY.